Let's talk about the mathematical functions that we can use in C and C++. We already talked about few of them, some of them, and we know that mathematical functions are found in the mathematical header library, CMath, and this is the library that contains most functions that you can use for mathematical operations. Let's look at some of them. So if you want to do factorial, for example, you know that you can do factorial is the multiplication of the numbers in a sequence. So for instance, 5 factorial is 5 times 4 times 3 times 2 times 1, and this is 120 total. But you can also do squared. So r squared is a function called power, in short is POW. So if you want to do the variable, which could be int, could be float, whatever variable that you end up having, the power will take that variable and square it or do the third, fourth, fifth power. This is where you choose what power you're gonna end up raising the variable to. Square root is sqrt, and we have absolute value for int as well as absolute value for floating numbers. So evidently absolute value of an int being -2 will be +2, but absolute value of -2.1, this is +2.1. So depending on the variable, you need to choose the proper function. Another very common function is the random number function. So the random number function by itself generates random numbers from 0 and 1. And the random number function, what it does is using the clock and different operations, it will generate a random number between 0 and 1. And if you want to generate a number between 0 and something else, so for instance 0 and 5, you can change the configuration to do that. So for instance, you want to say random number from 1 and 6. So you create a random number between 0 and 5 and then add 1 to the result, for example. That is an easy way to do it. So the random function by itself, it will be only between 0 and 1, but by adding the module or percent number, it will extend the random number to a limit. Another thing that you can do is add a seed, and this is more into statistics now, but if you use the random number by itself, rand r equals, say, rand by itself, every time you run your program, this will give you a different value because it's going to be random. But if you use a seed, it will give you the same random number every time you run it. So why do you use this? This is used because when you're designing a code that is going to do statistical analysis, the first time you bug and create your code, you want it to have the same number to make sure that you're getting consistent results. And then when you validate your code, then you can remove the seed and obtain the random numbers for a code that is validated. But if you design your code with random numbers and every time you're getting a different input, then it's hard to know, it's tough to know if your output is correct or if is an error, meaning that it's correct because the input changed, or it's incorrect and you have a bug or an error. That's why when you design your code, you always create a seed so that you get the same random numbers, and then when it's validated, you remove the seed. So let's look at an example for random numbers. Sorry, for factorial numbers. This is the first example we're gonna do about factorial. So we're gonna go to our dev++, and we're gonna create a new file, and we're going to start by adding our libraries. So first thing we need to do is we are going to include our IO stream, input output stream, and then we're going to start using namespace standard, and that's because we're going to do a console out, so we're going to use the namespace standard, and we're going to create a function. We know how to do that, and we're going to call it factorial, and is going to have as an input a constant int, which we're going to call input, and it's going to have another input, which is going to be a constant int sum, and we can define this as sum equals 1. So in this case, the user only needs to write as argument input, because the second argument we are going to force it to be 1. If you don't put 1 here, then the user will have to also input the value for sum. But let's force 1 right now to make it simple. So if the input that the user will write is greater than 1, we're going to return an int. We're going to return, the return is the factorial function of input minus 1, comma, sum times input. Okay. And we're going to say return sum. In this particular case, we need to create parentheses because it's an if. And since we're doing a single line, we won't need brackets. But we will need return sum, a column here, and we need a column here. Now let's create our main function. So main curly brackets, return 0, and then return 0 is because we're creating a function that is expecting a return. So we're saying, okay, since you want to return, we're going to return a 0. If at the end I'm able to return a 0, means that this whole function is successful. This is just the standard. Somebody asked, why 0? Well, this is the standard for saying it made it to the end, it worked fine, but if it makes you feel better, you can write a 7 here, return 7. It's just saying that the main function of my code is type int and it needs to return something. If you don't return anything in a function that has type int, then you're going to get an error because it's expecting something in return. All right, so what we're going to do is we're going to say console out and pass 5 factorial is, then write my function factorial 5 and line. Okay, let's see if we get any errors. And yes, we have an error. And it's because this is not cost, this is constant. And this is not cont, this is constant. Constant. All right. Return sum. It's giving me errors at return sum. So let's see, why is that an error? Oh yes, because return is on. Okay, we need to have this inside my function. So inside my curly bracket. Run again. Any more errors? No errors. When I run it, I get the 5 factorial is 120. So notice that I didn't use the math library because I pretty much coded the factorial example. So in this case, if I, instead of doing 5, I put 4 and recompile it and run it, then it's 24, because 1 times 2 times 3 times 4 is 24. So what happens here is that, let's go back to 5. I'm creating my function factorial, and factorial, what it does is that it basically goes to my definition of the function, and it says there are 2 inputs, but the first input needs to be declared, it's 5. The second input doesn't need to be an argument because it's already equal to 1. So if input is greater than 1, which it is, we're going to do go back to factorial and put 5 minus 1, which is 4. It's going to be sum, which is 1, times original input, which is 5. And it's going to save that because you're going to return a sum, but needs to check here. If input is greater than 1, yes. Go back to input, and it's going to do this every time since my input was 5. So when 5 minus 1 is 4, then it's going to do 4 minus 1 is 3, 4 minus 1 is 2, and 2 minus 1 is 1. So at this case, it's going to stop. If we remove this equal to 1, then it's going to expect 2 inputs. See? So then we say, okay, 1. And run it, and it's going to be the same thing. So since I don't want the user to have to know that my trick is I'm gonna simply multiply times 1 the first time, 5 times 1, and every single time I'm gonna multiply by itself. I'm just gonna put sum equal to 1 and ask the user for the number that they want to have as factorial. In this case, is 5. But again, this is pretty complicated because you don't need to do that if there's already a math function that gives you factorial. Now let's look at one example about creating random numbers. And this example is applied to throwing a die where we want to get a number between 1 and 6. So we're going to have 1, 2, 3, 4, 5, and 6. And evidently the probability of getting any of these numbers is the same. So this is called a uniform probability, where the probability is 1/6 that you're gonna get any number. This is opposed to the Gauss probability, which is something like this, where the probability of getting the value in the middle is the highest. This is opposed to getting a Gauss distribution, where the probability of getting the value in the middle is the highest. Uniform probability says that any number could be obtained having the same probabilities. In other words, you can have a 2 as well as you can get a 5. Opposed to the Gauss distribution, which is saying the majority of times you're gonna get your probability in the mean of the event or the average. So let's look at how to create this code, and we're going to go back to dev++, and we're going to create a new file. And for that, we're going to also use our standard input output, so we can create our console out, stream, and then we're going to use our C time, which is a way to obtain time seed, and we're gonna use our C standard library, which also has our random function. So first of all, let's use our math, C math. So include C math, and we're going to create only one function, which is the main function, parentheses, open curly brackets, return 0 for successful operation. And we're going to say there's an int called die equals 0, and we're going to send, or we're going to create a seed, which is rand, where first of all, let's create the random number without the seed. So let's say that die equals rand and we're gonna output that value. See out the random number is, and let's go ahead and output that number with our variable die, and let's do end of line. So if I were to run this case, we're gonna say random example1 is saying that rand is not found. There's a function called rand that is not known, and in that case, what we need to do is include our C standard library, and let's see if I still get an error. Yes, because it's C standard library. And now it's saying that die is not, and line is not declared. Yes, and it's because we're using name space standard. Okay, so if I go back to my C math, still don't get any proper results. So the function that the library that has the random function is C standard library. And in this case, if I run it, I have 41. Okay, and notice that I get a 0 here. Therefore, that means that process completed successfully. Okay, so I'm getting 41, and if I run it again, I get random number is 41. So let's compile it again, and let's run it. The random number is 41. Compile it again, run it, it's 41. Okay, so in that case, let's create the random seed so that can start at different places, and we're going to do include the time library, C time, and we're going to say that s rand at time 0. As rand times 0. Very well. And now it's changing. 29,436. And now it's changing again. 29,459. So by creating the seed, I'm using the clock to generate different random numbers. So before, without the seed, it will always be the same random number. That's why the seed is important. So to clarify, without the seed, I think I misspoke earlier. Without the seed, the number will always be the same. And this is good to validate your code. And once you have your code validated to do statistical operations, you can insert the seed and call for different random numbers. Okay, but what we want is to cap the results at 5. So we're going to do %6. And by doing that, we should get a number between 0 and 5. Run it again. We get a 5, get a 0. And in that case, since die can only give us a number between 1 and 6, we're going to add 1. So compile it, run it. It's 1, 2, 2, 6. So in this particular case, is truly random, giving us values that we can obtain by throwing the die. To conclude, the random number will give us a single random number every time. But if you want to obtain different random numbers, you have to create a seed, and it's truly random based on different computations that the compiler does internally, which are based on clock numbers. So it takes the time and uses that as a seed and then computes a random number.